Hey guys, welcome back to another video. This is an educational video. It's for my chemistry project, and it's over the atomic theory timeline. And to start off the timeline, we have Democritus. And this is his pretty much model of an atom, because he was actually the first person to discover the atom. And my sister here, who's in 6th grade, her name is Mackenzie, she's going to be reading more about him.
Okay, so Democritus was born in
Abdera,
Thrace, around 460 BC. Although there are disagreements about the exact year, his exact contributions are difficult to disentangle from those of his mentor Leucippus.
Yes.
As they are often mentioned together in text. Their speculation, sorry, I can't do anything, on atoms taken from the Leucippus bears a passing and partial resemblance to the 19th century understanding of atomic structure that has led some to regard Democritus as more of a scientist than another Greek philosopher.
Okay.
Oh, okay. I got you.
Alright. Next, we have John Dalton. And this is his atomic theory. And this is what he pretty much came up with as a model. And my sister is now going to read more about him.
All of this?
Hold on, guys.
All the way to that?
Yeah.
So, just this.
Yes.
The most important of all Dalton's investigations are concerned with the atomic theory in chemistry. While his name is inseparably associated with this theory, the origin of Dalton's atomic theory is not fully understood. The theory may have been suggested to him either by researchers
on ethylene
and methane, or by analysis of nitrous oxide,
yes,
and nitrous dioxide.
Nitrogen
dioxide. Oh my gosh. Both views resting on the authority of Thomas Thomson, not Edison. He made the light bulb.
Alright, next we have Sir J.J. Thomson. And this is his atomic model that he came up with. And as most of y'all know, it is called plum pudding.
Why is it called that, Zach?
Because it looks like, if it was colored, then it would look like you have little pink spots inside like a brown spot. Or, as you can see, it would actually be red because, red is negative. And now my sister is going to read more about Mr. Thomson.
All of this? Okay. In 1897, Thomson showed that cathode rays were composed of previously unknown negatively charged particles, which he calculated must have been
must have bodies.
much smaller than atoms in a very large value. Their charge to mass ratio, right?
Yeah.
Thomson is also credited with finding the first evidence for
Isotopes
of a stable, non-radioactive element in 1913. As a part of his exploration into composition of canal rays, his experiments to determine the nature, right,
Yes.
of positively charged particles with Francis William Austin, I don't know, were the first use of mass spectrometry and led to the development of the mass spectrograph.
Oh, also read this really cool fact.
Another fact is Thomson was awarded the 1906 Nobel Prize in Physics for his work on the conduction of electricity and gases. Yeah.
Next, we have Mr. Ernest Rutherford. And he pretty much came up with this model, which shows pretty much the ways that electrons can circle around the nucleus. And now my sister is going to read some things about him.
I can't read all of that. All the way down to there?
Mm-hmm.
Or just from this to
early
that?
In early work down to right.
Okay. In early work, Rutherford discovered that the concept of radioactive half-life, the radioactive
element
radon, and
differentiated
and named alpha and beta radiation. This work was performed at McGill University in Canada. It is the basis for the Nobel Prize in Chemistry he was awarded in 1908 for his investigations to
disintegration
of elements and the chemistry of radioactive substances, for which he was the first Canadian and
Oceanian,
I don't know, Nobel
laureate.
Alright,
and next we have probably the most known guy, and it is Mr. Niels Bohr. He is known for creating the Bohr model, which is pretty much what y'all all know, and it looks like this. Now my sister is going to read some more about Mr. Bohr.
Bohr developed the Bohr model of the atom, in which he proposed that energy levels of electrons are discrete and that the electrons revolve in stable orbits around the atomic nucleus, but can jump from one energy level or orbit to another. Although the Bohr model has been supplanted by other models, its underlying principles remain valid. He conceived the principle of complementary that items could be separately analyzed in terms of contradictory properties, like behaving as a wave or stream of particles. The notion of complementary dominated Bohr's thinking in both science and
philosophy.
Yes, there you go.
Alright, and next, probably going to say his name wrong, but we have Mr. Erwin Schrödinger. It looks like it is German. And this is his model. Now my sister is going to read more about Mr. Irwin, and
all the way down to here. Okay. Erwin Schrödinger was a Nobel Prize winning Austrian physicist who developed a number of fundamental results in the field of quantum theory, which form the basis of wave machines. Mechanics. He formulated the wave equation, stationary and time-dependent Schrödinger equation, and revealed the identity of the development for the formalism and matrix mechanics. Schrödinger proposed an original interpretation of the physical meaning of the wave function.
Alright, and last, but certainly not least, we have Mr. James Chadwick. And
Sir James Chadwick.
And this is, I don't know, it looks like every other model, just a little bit before him, but yeah, this is his model that he came up with.
You have your proton, your neutron, and your electron. We learned about that in school.
Okay.
This whole one?
Yeah.
Okay. Sir James Chadwick was a British physicist who was awarded the 1935 Nobel Prize in Physics for his discovery of the neutron. In 1932, in 1941, he wrote the final draft of the Maude Report, which inspired the U.S. government to begin a series of atomic bomb research efforts. He was the head of the British team that worked on the Manhattan Project during the Second World War, and he was knighted in Britain in 1945 for his achievements in physics.
Alright, well, after all this, we are done, and we thank you for watching, and have a good day.